Hi everyone. In the last session, we are seeing how to search for a particular node in single linked list, and now also we are seeing what's the problem in linear data structure. Now we'll be discussing about modifying a node value in single linked list, and now to modify a node value in single linked list, we'll be following this three steps. And the first step is going to be checking whether a single linked list is empty or not. And if single linked list is empty, then we need to use some message that single linked list is empty. If that is not empty, that means there are some nodes in the list. Now what we need to do is we need to accept the node value which the user want to modify, and we need to check whether that value exists in the list format. If that does not exist in the list, we need to use some message that no node exists with that value. If that node value exists in the list means we need to modify that node value. Right? So these are the three operations that we are going to perform in order to modify a node value in a single linked list. Right? Now let us check one by one operation, like checking whether the single linked list is empty or not, and how to check it. At the time of declaring, defining the structure, we are taking null in start pointer. When we call this modify function, when we are executing the program, if still your start pointer contains null, means then we can say that no nodes exist in the list. And this is how we are going to frame the logic. If start equal to null means then we are going to print some message that your single linked list is empty. Single linked list is empty. Right? So this is the first step. Now let us enter to the second step, that if node exists in the list, if there are some nodes in the list, then what we need to do, right? Let us assume that we have 4 nodes in the list. After that, we need to accept the value which the user wants to modify, and we are storing that in some variable called n. In some variable called what? N. Now let us make an assumption that the value of n is going to be 30. That means the user wants to modify the node value 30 to some other value. And for that purpose, we'll be going with this instructions. The same instructions what we are seeing in search, here also the same instruction will be there, except if part. There are some modification will be there in if part. Only one instruction we are going to add in if part. And what is that instruction and how to add that will be discussed. Right? So let us go step by step here. And the first step is going to be, will be assigning start to temp. That means start contains 1000, and that 1000 has been assigned to what? Temp variable, so that your temp is pointing to what? First. And after that, we need to check we need to enter into the while loop. Inside this while loop, we'll be checking a condition that 1000 not equal to null, and 1000 not equal to null condition is going to be true because there are 4 nodes in the list. The condition is going to be true, and after that, we'll be entering into the while loop. Inside this while loop, we have an if part condition that 10 arrow data. 10 is pointing to the first node, and 1000 arrow data. 1000 arrow data equal to n. So 1000 arrow data means what we have 10, and that is equal to n. And what's the value of n here? The value of n is 30. So 10 equal to 30. Condition is what? False. That means the user is not interested to modify the first node. So if that was the case, then what we need to do is we need to make attempt to move from first node to what? Second. And for that, we'll be going with this instruction. And this instruction is going to be the famous instruction in a single linked list program, which is used to shift your pointer variable from one node to another. Right? So temp is assigned to temp arrow link. Earlier value of temp is going to be 1000. 1000 arrow link is going to be 2000. So temp has been moved from 1000 memory location to what? 2000 memory location. After that, again while loop, and this is going to be the second iteration. 2000 not equal to null, condition is going to be true. If that condition is true, means I'm entering into the if part. And inside this if part, again 2000 arrow data is equal to nr. 2000 arrow data means what? 10. 10 equal to 2000 arrow data means what? 20. 20 equal to n. What's the value of n? 30. So 20 equal to 30 means condition is false. It doesn't interest in the if part. Then again we need to move temp from current node to what? Next. That means from second node to what? Third. Again we'll be going with this instruction. Temp is assigned with what? Temp arrow link. That is 2000 arrow link. We'll be having 3000. 3000 is going to be temp. Temp goes from 2000 memory location to what? 3000 memory location. And after that we'll be going with while loop that 3000 not equal to null, condition is going to be true. And if that condition is true, it send us to the while loop. Inside this while loop, we have got temp arrow data, that is 3000 arrow data. 3000 arrow data is 30 is equal to end value is what again 30. This case both are true. Now what we need to do is, if what match is found means we need to modify the node value. And question raises from your end, how to modify the node value. How to modify node value. And with the help of scanf statement, we are taking scanf percentile d ampersand of temp arrow data. So temp is pointing to which one? 3000. And the user wants to replace 30 with some other value. So that's the reason I'm going to take temp arrow data, ampersand of temp arrow data. I know that temp arrow data contains value called 30, but I'm replacing that 30 with the user interested value. Let us make that let us assume that the user entered a new node value as 100. Then 30 will be replaced with what? 30 will be replaced with what? 100. Right? So this is how 30 will be replaced with 100 by using this instruction. By using this instruction. Right? So now the final linked list is going to become like this, and this is how the modified operation is going to be performed in single linked list. And you might be asking a question that suppose, sir, here we have what? 4 nodes are there. Out of the 4 nodes, you are taking unique values 10, 20, 100, and then 40. Suppose I would like to search, or else I would like to modify a value, and that value exists 2 times in the list. Let us make that 10 exists 2 times in the list, and I would like to search or modify for them. And you might be getting a doubt whether 10 which value I would like to search. The first first node value I'm going to find, or the last node value I would like to modify or search. So in that case, what happens is, if we follow this procedure, so whatever the value comes first, and that will be considered. Suppose 10 present 2 times here, and the first 10 is going to be identified as what element is found in case of such operation. Whereas in case of modify operation, the first node 10 is going to be modified. 10 is going to be modified. Right? So that is a different case. That is a different case. Right? So this is how the modify operation that we are going to perform in case of what? Single list. Let's have a look on coding part of that. Right here, I'm taking same n, which is used to accept the value from the user, and f, I'm going to assign with the value as 0. And if I found the element in the list means I'm going to make the value of f as 1. Right? So if start equal to null means I'm going to print some message that single linked list is empty. If that condition is false, means it enters into the else. If that condition is false, means what's the meaning in that? There are some nodes in the list. Now, if there are some nodes in the list, means I need to ask the user enter which node data you want to modify, and I'm going to accept the info of what? Scan, and then I'm going to assign start to what? Temp variable. And after assigning start to temp variable, again we will going with the while loop. How we are done in case of modify operation. So such operation is same thing, right? So if we find the data, then we are making the value of f2 what? 1. After that, we are asking the user enter node value, and the user is going to enter the value. That value I'm going to store in what? Temporary update. They means it comes out of the while. After coming out of the while loop, we are checking if condition, if at all the value of f is equal to 0. If the value of f is equal to 0 means, then I'm going to print no node exists with that value. If I find the value, then the value of f is going to be changed to what? 1. If that is, if f value has been changed, means this printer is not going to be executed. Right? So this is how the modify operation is going to be performed in single linked list. And with this, we covered all operations starting from creation, inserting a node as a first node, last node, after any node, before any node, and then display what deletion, search, modify, all these operations we covered along with coding. Now, in the coming session, we'll be going with the double linked list, and what are all operations that we are going to perform on double linked list. And just like how we are done single linked list, in the same way we'll be going with the double linked list also. Right? Thank you.